Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the Geospatial community. My guest on the show today is Jason Gilman. He is a principal software engineer at a company called Element 84, and today on the podcast we're discussing the concept of natural language geocoding and its significance in converting textual descriptions of locations into precise geographic data. So this involves using large language models, LLMs, to interpret a user's natural language input, such as the coast of Florida south of Miami, and transform it into an accurate polygon that represents that specific area on the map. This process could dramatically simplify how users interact with geospatial data, but it's not without its challenges. Just quickly before we get started today, I think this episode will tie in really nicely with a previous episode called Semantic Search for Geospatial. So if you enjoy this one and haven't checked out the previous episode, I suggest you do that. Okay, let's hear from Jason about natural language geocoding. Hi Jason, welcome to the podcast. Thank you very much for taking the time to talk with me again today. I really appreciate it. And just so the listeners know, if it sounds like there's a little bit of inside jokes along the way during this conversation, it's because we've talked a couple of times before. And due to sickness on my side, it hasn't really worked out in terms of recording. So I'm very hopeful for today. I'm feeling much better and I'm still really excited about a topic, which is natural language geocoding. But before we get into all of that great stuff, would you mind just briefly introducing yourself for the listeners, please?
Sure. Yeah. And thanks for having me back to do it again. So I'm Jason Gilman. I'm a principal software engineer at Element 84. And Element 84 is a small company in Virginia. And we've got a bunch of people in Philadelphia, but we're kind of a remote company. And I've been working there about 14 years. So I've been doing a lot of geospatial work over my career, building systems for searching or science data, thinking about how to make that better, mostly like on the back end API sides and also cloud work. And over the last 6 months, I've kind of shifted to doing a lot of AI ML work, looking at large language models and vision models and things like that.
So that's the bit that I really want to dive into today. But just, you mentioned over the last 6 months, you've shifted to looking more into this AI, ML techniques that are possible. What has changed in the last 6 months? Have you just had time for it? Has your company just decided to prioritize this? Or has something changed in the AI, large language model landscape that has made this possible?
Yeah, I think maybe for me, something triggered. So there's a lot of people who've been working in machine learning for a long time. So I'm not one of those people who has like a deep history of it, but I think I bring a different perspective on it. And I just realized that there's been this giant influx of new ideas, new capabilities. And I started to see how you could take some of these different components, vision models and large language models, and start to plug them together to make some of the things that I was trying to do previously a lot easier. Like when I was building APIs for letting people find Earth science data, or like thinking back to what are they really driving at, and things like Amazon Bedrock, where a lot of the work that I do is in AWS, the Amazon Web Services in the cloud. So things like that started to make it easier to use some of these models where you didn't have to run anything. You could just start calling them. And also just working with some of the great coworkers that I get to work with and learning from them. Like I started to get really interested in this and pushing in what was possible.
Now I think we've probably teased it enough. Let's talk about what you've been doing, what you've been working on. The title I've got in front of me is Natural Language Geocoding, but perhaps you could put some more words around that for us, please.
Sure. So when I think about users, a lot of the, finding science data, what's driving them is they have questions that they want to answer. And I also use the same train of thought in my presentation, so I've talked about it a bunch. But when they're thinking about these questions, with large language models, we get to the point now where people can just ask a question and we can start to automate things that will just provide the answer back to them instead of them having to jump through hoops to do it. And I realized one of the challenges, like almost all of these questions would be a user describing in text a place on the earth, some area. And sometimes they're simple areas, like they're saying, Florida, and sometimes they're more complicated, like the coast of Florida, south of Miami, or the Florida Keys on the southern side or something like that. And so natural language geocoding is being able to take that natural language description of a place on the earth and be able to convert it into a real polygon. And so then we can go do, whatever we want with that in terms of searching for data or processing something.
Okay, so this is a great starting point, but I need some more information out of you. What does that mean to turn it into a real polygon? Because I think a lot of people will have seen examples, perhaps even tried themselves with something like ChatGPT. Hey, create the bounding box of, I don't know, Florida for me, or create this polygon for me. And there we're talking about generating the data. Are we also talking about generating data when you talk about turning natural language into a real polygon? Or what does the process behind it look like?
You can ask ChatGPT or an LLM to say, give me a bounding box, like the set of points that surround some area. Or, you could give it the other descriptions and it will do its best to try and give you back that answer. They've been trained on a lot of input data. So they actually tried before with ChatGPT to say like, okay, give me this area. And they're not actually that great with that in terms of getting you the most accurate thing. And I didn't even start out with that idea. The idea I started out with was when I'm used to, building APIs, when a user describes against the API, it would take JSON that describes like, here's the data set that I want, here's the time range that I'm looking for. And then they would give you a polygon that describes, all the points on the earth. So I'm used to taking these pieces of data that describe the kind of data that they want and then being able to go and find it. And so I thought of using the LLM to be able to do that, to be able to convert from a natural language description of a spatial area into a data structure that represents what they're asking for. So if a user says, or actually I'll just do the natural language portion of that, give me the coastline of Maui. You can think of that almost as like two separate things they're asking for. Get Maui and what that spatial area is, and then get the coast of that area, the part between land and the water. So the way that I do it is I give the LLM a prompt, and that's what it's called when you pass in some text to a large language model. It's called a prompt. And I would say, okay, your job is to convert from this user's natural language description of an area into a JSON structure that represents different things. And like the items in the JSON can be things like look up an area based on a name, compute a coastline of an area, combine two areas together like a spatial intersection or a join, or find the difference of areas, things like that, or find everything west of something, of some particular point. And what the LLM is able to do is I give it this JSON schema and the user's area that they're looking for. And the LLM is able to understand the JSON schema, understand what the user has written, and then be able to give me back a piece of JSON that represents the sort of the work that I have to do to convert it into a real polygon. Let me see if I can make that a little bit clearer. So if you're asking for coast of Maui, what the LLM will return back is look up Maui, get coast of it. Like basically two things related together. And then because now, instead of just having this string of text, I now have two discrete things that have to happen. It's easy to go implement that now, or it's easier than having to figure out what they're saying in text, that I can go look up in a thing like OpenStreetMap and say, give me the polygon for Maui. And then you can say, okay, now compute the coastline of that. And that's just regular spatial calculations to do it at that point. And so it's this combination of building a prompt to the LLM, sending the prompt in with, what the user typed out, and then you get that response back, and then just computing it at that point.
How specific does that JSON schema need to be? Because it sounds like you're almost describing what is possible within this interface. You talk about this is a description of work. So buffer a point, extract some data, things that are west of or close to. It sounds like you're describing like what is possible within the interface in terms of user queries.
Yeah, it has to be really specific in terms of the LLM isn't going to invent new JSON or types of spatial intersections because I won't know how to handle them if it comes up with some other one. I have to tell it like, here's everything that I know how to do. I know how to compute a union, an intersection, differences, lookups, compute coastlines, like all these different things. And then it's the LLM's job at that point to figure out from those pieces how to represent what the user's asking for. And sometimes if the user, like if you didn't realize that a user might ask for something in some way, the LLM will do a bad job of it. Naturally, like if the user asked for, give me the area between 2 points, and I didn't have already like written that out, it wouldn't be able to represent it in the JSON structure that I gave it.
Could the LLM help write this JSON structure? Given a set of endpoints and capabilities, like, okay, at this endpoint you can do these 5 things.
Could you clarify that?
Yeah. So remember when we used to have to fire off like a get capabilities request, and you'd get a set of instructions back from your WFS server or whatever it was. Great. Oh, you can do these 7 things. You have these processes, and the processes would be written out. So yes, you can, I don't know, calculate a bounding box or whatever it was. But the point is, I had a list of capabilities. I'm wondering if my endpoints also could deliver a list of capabilities. So at this endpoint, you can do these 7 things. Could the LLM read that and then use that to create a suitable JSON schema?
Yes. Yeah. I think I'm getting what you're saying. I think you might be talking about some different things. So when I give it the JSON schema, like I'm fully defining what that JSON schema can do. And I did use an LLM to help write that JSON schema, like first in terms of helping to write the code and come up with the idea, use ChatGPT and other LLMs to try to figure out like, okay, how am I going to write it?
Okay, so that's exactly what I'm talking about. I'm not talking about doing this on the fly.
Yeah.
For each and every request, I'm talking about these capabilities of this particular API are not going to change over time. So let's read some documentation around them and use that documentation to prompt an LLM to help create this JSON schema.
Yes. Yeah, you can do that. And that's how I did. Like I told an LLM at the beginning, or ChatGPT, I should say, that's what I was using. I want to build something that allows a user to type in natural language and be able to convert it into a real polygon. And I think it might work this way. Does this sound like it will work? And ChatGPT responds like, yes, that would work. And give me some ideas on it. And then I would say like, okay, well, what are the different kinds of elements I might have in my schema? And then it gave me like a bunch of different ones. And you don't use it like verbatim what you get back, but basically it becomes sort of like a partner for your development in terms of like bouncing ideas off of it. It's like the rubber duck idea where you're going to like explain a problem to a rubber duck, and just by explaining it, you figure it out. But in this case, it's talking back to you and it's giving you good ideas of what to do.
Yeah, it makes a lot of sense. It's also really interesting, the idea of partnering with an LLM. You know what I mean? Like having the sparrings partner that you can chat back and forth with. I think that's kind of fascinating. How does this tie in with the idea of agents? Or could it tie in with the idea of agents?
Yeah, agents are a concept for like if you have APIs out there or like multiple different kinds of tools that you might use in order to solve a user's problem, you can just tell the LLM, here's the problem that I want to solve, and here's a bunch of different capabilities that I have, and which might mean looking up, like searching for different data set types. It might be searching documentation, computing, doing the natural language geocoding portion, anything like that. So with an agent, you give the LLM in its prompt, here's a list of tools, here's how I would invoke them, here's the user request. And the LLM will say, okay, the first thing I need to do is this. And then your code then needs to take that response and then go and call that, that other thing, and then give it back to the LLM and say, okay, this was the user's problem. This is what you said I should do. I just did that. Here's what I got back. What should I do next? And then the LLM will keep iterating back and forth until the LLM decides it's done. I have an answer.
Just so I'm clear, this is not the approach that you took when you implemented this natural language geocoding. You wrote custom code as opposed to using agents. Is that correct?
Yeah, I would think more of what I did is one of the tools that an LLM could use as part of it. It's one piece of a larger thing, right? When a user asks a question saying like, find me algae along this coastline, one of the problems is, okay, well, I need to figure out where are they talking about? And then that would be one step. And then another step might be, okay, where can I actually go and find algae type data? And that would be an LLM maybe searching for among different data sets. And then the response back from that would be like, okay, these data sets you can find algae with. And then it would be at that point, LLM saying, okay, now search that particular data set with the spatial area we got from this other step, and then get the answer back for the user.
It sounds kind of amazing and very, very futuristic that we can just start talking to these machines, you know what I mean? And getting information back, show me the bottom half of the Florida Peninsula and then do this thing, on that data. It seems fantastic. What have you struggled with, or what kind of limitations have you run into along the way? Because I can imagine things like the way we describe stuff is not always the easiest to understand. And maybe people aren't very clear at giving instructions, or this idea of close to, around, like within walking distance, things that us humans might understand or have a decent idea of about what's being talked about in terms of distances. Machines might struggle with this. But those are just some of my ideas. But what have you run into in terms of limitations or challenges?
There's definitely you need to do testing and try it with a lot of people where you see how do they actually phrase things and see what happens when the LLM gets that. You can also use an LLM to generate what are some different ways people could search it that might break it. You can ask for that and it'll give you good searches back, and then you can test those. And then when they fail, you can say okay, and how would I fix this? So you have to do some iteration, and the LLM is part of the solution too, in terms of fixing it. Some other problems can be the way that people describe areas can be something. So I'm using OpenStreetMap's API in our natural language geocoding. And so OpenStreetMap will have a city like Paris, and it will definitely be in there. And it will have things imagine Key West. You can look that up and it'll get the polygon back. But when somebody says a larger kind of broader area, like the Florida Keys, that may or may not be in OpenStreetMap. And I found it is in there, but it was just added by one person and it's a single point. It doesn't have the polygon for the whole thing. And there's similar problems too, where somebody might say the Rocky Mountains, right? Which is just a giant area, across Canada and the United States. And there's similar things like the Congo River Basin is another example where it might have the Congo River in OpenStreetMap, but it might not have the other things. And so part of it is you need to understand the domain of the user that you're trying to figure out. And if you're starting with a database that's like OpenStreetMap, so it's populated with volunteer data and it has a lot of businesses in it, and I'm doing things for science that might be, have specific use cases, something I could do is go out there and try and find other specific sources and try and put those in there as well.
This sounds like more a limitation of the data set that's being used as opposed to the technique that you're employing.
Yeah, it's a bit of that. I guess it's a lot on the missing data part, but it's also on people describing just natural areas that aren't actually an operation. Somebody might have a particular thing. They might, if you live in San Francisco, you might call it the Bay. And so when somebody says the Bay or similar for whatever their area is, you have to figure out what do they mean? What is that?
Have you also run into things where it's difficult to understand or tease apart in exactly what order the operations need to happen in?
There is that, but it hasn't been as big of a problem as you'd think. Mostly one of the first problems that I encountered was it would come up with way too complicated of a solution to come back with it. It wasn't the simplest way. It would say, look up this, look it up again, do an intersection or a union. It would just make really complex trees. And so, working with the LLM to say here's the problem, what should I do? It said okay, add this instruction in that will say generate the simplest tree possible. And it would have the right wording in there that would be the most effective.
Wow. It's pretty amazing when you describe it like this. The spatial temporal asset catalog. So I think of this as a way of cataloging Earth observation data, and it feels a lot like a sort of keyword search problem. I'm really interested in finding, I don't know, images of the Earth that have snow or show me vegetation or whatever else. Could I put something like this kind of natural language interface in front of a stack catalog and search it, do you think?
Oh yeah, definitely. That's one of the demos that I built, in addition to natural language geocoding, also built natural language stack. So you can say, find me Sentinel-2 data over, Ontario with snow, and it'll be able to, the prompt that I give in that case is I tell it that natural language geocoding is one of the things that it can do. Like it should extract out the spatial area, but that it also, I tell it like, okay, here's the different collections or data sets that are available. And here's the particular properties of them. So it knows when it's searching for Sentinel-2 data that snow ice percentage is one of the properties that it can search on. And that's a percentage. And giving the LLM like all the information then really lets it know, okay, then I can do that. I'm going to produce a JSON output. And with a little bit of processing, I can go then and take that and search the stack catalog.
It's interesting. So I've just realized up until now, we've been talking about, natural language geocoding. Is there any reason why this couldn't just be natural language geoprocessing?
Oh yeah, absolutely. Yeah, I think it's like it all falls under an umbrella. I think of like what I call, it's not just me, but geospatial AI ML.
Right. And this, so not just finding data, retrieving data, that search function, but also processing the data as well.
Yes, exactly. And we've been thinking about and writing proposals and things for systems that can go the whole way, where a user says, I want to know this particular thing about salinity, and I want you to correlate to data sets and like be able to take an instruction for the user where they're correlating, let's say, carbon dioxide in the air and salinity, and be able to say, in the Gulf of Mexico, and then get back a map showing that, or a graph or something like that. And we're, thinking about like what are all these different parts that we can put together to make that answer come back.
So I think when we start thinking about kind of starting to answer questions like that, this idea of reproducible research becomes more and more important, like show you're working. And I would be worried that, let's say there was an update to the underlying LLM, suddenly I couldn't, just use the same prompt tomorrow and get the same answer. I couldn't reproduce my work. Have you tested this?
I haven't had that specific problem. I mean, if you switch from one, I'm sure it could happen if you did it, but mainly when you're using the models. If you're running it yourself, I mean, it's like you're running that model and it's not going to update out from, underneath you unless you're like doing that yourself. It's like using a software library. When you deploy your code, you set up, this is the code that's being used and it's not going to change unless you change it yourself. When you're using it, one of these models run by another company, like as a cloud service, you specify like, here's the specific version that I'm using. And I haven't been using it that long. And this is like all like a new area, but I haven't had that problem where the model changes and something happens there.
Okay. So maybe that was a little bit of a silly question. I understand what you're saying, and it makes perfect sense to me. But I also know from my own experience that sometimes I just get different answers and the prompt can be basically the same.
Yeah. So that's definitely true. LLMs are non-deterministic. So even there's different parameters you can give them where you can say, like, one of them is temperature. And what that says to the LLM is like, what next token, as it's generating tokens, is it likely to pick? And the lower the temperature, the more it's likely to pick just the most obvious next token. And so one of the things that we do is like set that temperature down to 0 so that it tries to be as deterministic as possible. But even things like changing the GPU with the same exact model, same exact input, like will produce different results. And so there's like so many other like little things that could change where the answer that might come back. I think that's one of the biggest challenges with these. I mean, among the other ones in terms of security and ethical use and bias and, all these other problems that are there. I mean, we like systems where we know we put the same thing in, we get the same answer every time. And especially for science, that's a big problem. And so we're thinking about different ways to handle that. I do have one that I can talk about too, related, that we're doing or thinking about anyway.
That'd be great. Like some kind of solution to this I think would be really interesting to hear.
Yeah, I had heard about this idea of process as data. I think it was from Noah. It's not like a new idea, but it's basically the idea of, in order to accomplish a task, some sort of process where we're going to get an answer, there's a set of steps. And we know what those steps are. And as you go through each one of those steps, you can build up what's called provenance in science. People might not be familiar with that term, but basically it means we want science to be reproducible, we want it to be reliable. And science isn't science if it's not open and you can't see what somebody else has done and be able to reproduce it. And so using an LLM, you have that problem of it can seem like a black box. You send in a question and you get an answer back, but how did it get there? And is it going to be the same the next time I ask it? But with the idea of encapsulating a process as a set of steps, as you do those steps, you're going to do them the same every time. And the way we connect that to the LLM is when a user asks a question, we use the LLM to figure out which set of steps, which process here that's already been defined is the right way to answer this question. And then once the LLM figures out, okay, they're asking for a correlation. Here's a set of steps I execute to do a correlation. We do that every time, the same way. And we're tracking like, here's the specific steps that we did. And so there's still the idea of like, oh, what if the LLM picks a different set of steps? That could be a problem. But at least like once it decides like, okay, this is actually, I'm going to do it this way, you're removing some of the potential for it producing just like different results.
Okay, so it sounds like you're basically describing processes that it can carry out. And so this is the exact recipe you follow when someone says correlation. This is what a correlation looks like. These are the tools that you use, and this is the steps that you execute those tools in. Is that correct?
Yeah, it's like LLM agents with a recipe.
Yeah. Is there any reason why, as part of sort of showing your workings, you couldn't provide the user with, okay, here is the result, and here is the process, the exact process that we used. So you could take this and fire it off somewhere else, or bring it back here in a week's time, and it would still give that same answer.
Oh yeah, that's the idea. You would definitely do that. Like for a scientist getting an answer back, they don't want to know just the answer 15. They want to know how you got to that answer. And so you would definitely do that. You would say, we got the answer by going through these steps, and we got the data that was here is from this particular data set with this particular time. It was from this satellite, these instruments, and it had these particular corrections made to the instruments. So all that stuff you would feed in, and you'd want to capture the other steps that you took along the way as well.
It sort of reminds me of this idea of chatting with data, where you talked about earlier, you were asking the LLM or having a conversation with it, what do you think of this? Am I on the right track? Do you think this will work well? Or could you simplify this? Do you think that's where ultimately we're heading, is this idea of the chat interface? It's a conversation with our data.
I think it's going to be a bigger part of interfaces. I am still like, even though I see so much potential there, I am skeptical about that being the best interface to use, that it's always a chat. I think it has to be a combination of, I can just type a question, but it's also going to continue to have all the great user interface techniques that we've been developing with maps and dragging and dropping and being able to like type in numbers on a particular field. Like I think it'll all be combined together. And I think that's where it will shine, is the idea that you're having a conversation with the tools that are there. And I'm still trying to conceptualize it, but it's going to be a conversation with all it being displayed back as text and maps and diagrams, and all the other UI elements are there. So I think it'll be like adding on to what we already have.
Yeah, I think too, it's also a little bit naive to think that this is going to be the one way of interfacing with data for everybody.
Yes, yeah.
So you've done a lot of work, and you've clearly done a lot of thinking about this. You've mentioned a few use cases along the way. Are there any other sort of use cases you'd like to highlight for us, where you think, oh yeah, if we could just implement this thing over there, that would be great? Or people, when we first show them this, they give me this example where, we should make one of those. Is there anything like that you've seen or heard about that people are particularly excited about when they think about this idea of putting an LLM in front of the data?
Yeah, there's a ton of different use cases we could think about. I think we talked about this before the last time, but I was thinking about how, like a lot of probably software engineer people, I'm pretty picky, right? Like finding what movie am I going to watch next? Where am I going to go on vacation? What restaurant am I going to pick? What am I going to order? Like I'm going to get a new backpack. And so you end up searching through, finding different things that you want. Like, let me think of like finding a vacation home, right? You're thinking of, well, I want it to be in an area where I can walk to different shops and things like that. I want it to be kind of close to this natural beauty. So I want it to, be able to go hiking. There's all these different categories of things. And you can imagine that when you're trying to build a UI that lets people pick, what they want to find, like if they're looking for a vacation home, you have this sort of opposing forces of it's got to be really easy, or else people will look at your website and think they're looking at a cockpit, an airplane with all the widgets and dials. It's got to be super easy. But then at the same time, you have to let people ask for what they want. And so the UI, you have that really hard challenge. And so I think there's a whole bunch of places where something like looking for a vacation home, where you could let a user ask for what they want, where all of the searching capabilities that they might want to do are there. They just need to ask for it. So you don't need to like figure out a way to expose those things.
Yeah, and that would be really interesting too. You don't need to call it a buffer. I think of this all the time. I arrive on some sort of web-based map, and then the tools they expose, what do they call the tools? I mean, oftentimes they're talking to people like me. Oh, it's a buffer, it's extraction, it's this, it's that, the other thing. Well, normal people don't talk like that. They don't think of a buffer around a school zone, or they think a radius around, or like a distance from, or that kind of thing. They don't use the word buffer ever, because what the hell does that even mean? And I think we would avoid that problem just by using natural language.
Yeah, and I really like that it's adaptable for the level of the user. So like a scientist coming in, or a person who just wants to know more about whatever, they can be an expert on it, and they can use their expert level language, and the LLM will understand them. Or you can be a regular user and use your different ways of referring to it, and it will understand that too. So it's adaptable in some ways, where like building a UI that works for airplane pilots might not work for somebody who also has to make it work for people who've, are familiar flying or driving like Mario Kart.
I think I know the answer to this question, but I'm going to ask it anyway. Do you think this is kind of the end of SQL queries?
No, it's not. And that was that the answer you were expecting?
Yeah, that's the answer I was expecting. But what is more interesting to me is not to get the answer back that I was expecting, is to hear your opinion on this. Why do you think that is?
I think it's like the SQL, right, is a language for talking about data that you're pulling out or making updates to data, right? And it does its job really well. I guess it is, in some ways, it's a human language in terms of expressing something. I guess it's also a programming language in terms of that you're being able to talk to a computer and tell it what kind of data you want back, instead of having to write code to actually go through and extract it. SQL is like this common interface that's there. And one of the great things is like LLMs can take advantage of SQL that are there. So you can tell a large language model in a prompt, one of the things you can do is search this database. And it's a SQL database and has these columns, and it contains this kind of data, and it has this relations to other tables. And the LLM can generate the SQL to go and get it. But then you still need to be able to use SQL from other parts where you're not taking natural language in.
Yeah, I agree with you. But I got to admit, I can see a world where this, you used the term before, common interface, common language, when you talked about SQL, the standard querying language. I'm really interested to see how far up the chain of abstraction that the human language moves. Is that going to be the new common language? Is it going to be the new way of querying things, the new way of writing code, just the new way of generally interacting with machines? And is it going to be, and how long is it going to take to get there? I think those are really interesting questions.
That is a really great question. Yeah, what happens to programming languages over time when LLMs are there and you're sort of accomplishing some of the same things you do with a programming language, right? You're describing to a machine what you want to happen in order to get an answer back. And it's in this way, the machine's doing a lot more deciding in terms of figuring out what you mean, whereas like programming languages are usually a lot more precise. But yeah, it's a really great question. It's definitely one like I'll be thinking about.
But when you think about, not that I'm an expert in Python, but when you think about Python, for example, there's a lot that's being hidden away from the user. And there is in the vast majority of programming languages, I guess, unless you're writing in binary. But it's building on top of all of these, at least in my mind, all of these other decisions that have been made. And when you call that function, there's a bunch of decisions that have been made. And for the most part, the user doesn't need to know or doesn't care about what's happening. They just push the print button or sort of execute the print function, and something gets printed on the screen. And I wonder if we're going to head in that direction with natural language as well.
Yeah, I think so. You were reminding me, talking about that way, of a Python tool called Dask. Have you heard of that before?
Yeah, I have.
Yeah. So for people who aren't familiar with it, it was trying to solve a need. I mean, it became really popular, so it definitely helped solve that need. But basically, people writing Python code would be writing code that worked well on one machine, like to compute something over data structures and compute some aggregations and things like that. And what tools like able to take code like that, but be able to take advantage of all many machines. So, and it was a great tool for thinking about the cloud where there's all these servers available. We want to use them for a little bit and then let them go away. What Dask does is it understands your Python code and it turns it into a directed graph of computations and then runs that all on multiple machines, accomplishing what your code would do, like running on a single machine, but much faster. That's like a really like layman definition of what Dask does, but it's the same kind of thing where it's like you're not describing precisely what the computer should do. There's that level in the middle where it's figuring out, well, I'm actually going to run it across 20 different instances and pull the data in this way rather than being like the precise do it this, do this, do this.
And I think sometimes we will really want the control where, do this, do this, do this. And other times we'll just be like, you know what, you figure it out. These are the resources you have available to you. And this is the code that I've written, figure out how best to scale this kind of thing.
Yeah. Yeah. I think there's a lot of people who are skeptical of these technologies that I've been thinking a lot about and people pushing back. I think they're rightly so. I don't want to say like that it's misplaced. I think that they can get there with over time. Like the promise is so big that it's hard to ignore it. And I think it's worth us looking into this because of what they can do.
I agree. I think the promise is really big. And I've got to say, up until now, it's one of those technologies where I thought they've made big promises and they've kind of kept them. Yeah, I could think of a number of other different technologies where you're like, oh, you didn't really deliver on that, did you? You made these massive promises and it's not really happening. But I think AI, at least in the large language model world, it's moving so fast. And I, as a everyday user, can see the difference. So I don't have to be an expert to, oh, look, I can see that's a microsecond quicker. I can see like, wow, this is faster. This is better than what it was a month ago. It's kind of amazing. It'd be interesting to see how long they can keep pace with that trajectory. But at the moment, I think they've made massive promises and they're delivering on them. Like whether they'll be able to deliver on this utopian future where everyone's just sort of lounging around and doing whatever they want all the time and the machines take over, I don't know. But it is astounding at how quickly it is moving, at least with my limited experience with it.
Yeah. And I've definitely seen the promise, at least in terms of being able to use these LLMs to help me accomplish problems. Like I have tools that work. Like one of the things we haven't talked about a lot is vision models. And that was something that's like, it's a little bit more challenging to work with than a language model, like passing in images and working with data. And there was problems that I had to try and figure out when I was rewriting some code. I was changing it from one library to another, and it was working with like these earth science images. And I hadn't done a lot of that particular kind of coding before. And so I didn't understand like what was going wrong. And I was able to just say like, here's the particular problem that I'm having. This is the code that I'm using. Like what could be going wrong here? And it would, I can't remember what the exact thing was. It might have to do with like normalization or something like that in terms of values, but I was able to point out like, oh, here's these specific parts of your code that like are failing. And then I was able to do it. And this is the kind of problem where like I've tried in the past where I'd be like, oh, you know what? I haven't dealt with this. This isn't something I've done for like 5 years. So I would just give up and like look for a different problem to solve sometimes, especially for like part-time work. And this is stuff that I kind of did on my own on the side. And it really just enabled me as someone who's unfamiliar with like some of this type of work to be able to accomplish stuff like, right. Like I don't have a big machine learning background. I'm a competent software engineer, but being able to take this and like, it's just like leveled me up so much.
It's kind of amazing when I hear people like you tell stories like that. Just as we sort of wrap up the conversation here, and we're talking about some of your personal use cases, I wonder if you could share any other examples that you might have of where you personally are using large language models during your everyday, or I mean, obviously with you, when you code, you're asking for help. Is there anywhere else you're using them and finding them helpful, or are there any particular tools that you're using that are helpful?
Yeah, the other things that I might be doing, like outside of code, is things like, oh, I found there's a restriction on a airplane that I want to like on the bag size, and it's in centimeters. And I could go, I know how to convert from centimeters to inches, but it was just easier, just copy and paste the description of the seat area in centimeters and be able to like paste that into Chat GPT and say like, okay, give me that back, convert this into inches. And it can just read the whole big post, which describes like, oh, here's your seat and you can bring this carry on. And it's also got the inches in there, or centimeters, sorry, and be able to give that back. Or like the other night, I was looking for scary movies to watch. And it's something where it's like, there's certain kinds of movies that I like where it's like, oh, I like aliens a lot. Like I like that kind of scariness, but then I don't like it where it's like ghosts and haunted houses type that are really popular now. And I was trying to describe like, I want this kind of like thrill and intensity, but I don't want it to be like this. And I was able to like make, I think I got like, there was a bunch of movies I had already seen, and I see a lot of movies. So there was 5 or so in there that were like, oh, you know what? I hadn't seen that one. And it did look good.
Interesting.
Yeah.
I think too, this gets a whole lot more interesting. One of the promises of these large language models is this idea that everyone gets a personal assistant. Once this assistant gets to know you, what you like, what you don't like, I think this process that you were just talking about, that becomes a whole lot more interesting. I don't know if you've noticed this, but when I've been using ChatGPT lately, you can see, oh, this little sign comes up from time to time, memory updated, whenever I type in something or say something that it thinks is significant. And it's really interesting to see what it's remembering about me. Have you noticed that?
Yeah, I have noticed that. And I think it makes sense as part of a product that they're offering. And one thing I do want to bring up too is that I'm not using ChatGPT for everything at work. Like some of the side project stuff I've used it for. But one concern I would have somebody listening to this might be like, oh, is he just sending everything to ChatGPT? But there's other LLMs out there. And one of the things like that we've not us figured out, but gotten approval for is running your own models, finding ways to run them where you're holding all of the data, or it's not being shared with anyone. And I don't think ChatGPT has all those guarantees. So for work like things where I'm might be using something that's not something that I should be sharing with third parties on the web, we use internal ones as well.
Yeah, that makes a lot of sense. And I don't think I truly understood the importance of companies like Meta open sourcing their Llama models, I believe it was, right at the start. But now, as I talk to more people like you and you hear these what they would like to use them for, it becomes more and more obvious to me why that was such a big and important move, because now you could take that and run it in your own environment.
Yes. Yeah. And you can control, like it's just running your own database, right? You're putting data in there and you're getting some answers back out. And just an LLM model can't talk to anything else. If you're running it yourself, you have complete control over it. You can run it, and there's people, and I've done this where you run it just on your local computer. There's great tools that let you do that. And nobody else has taken that. It's all running locally. And then there's things like Amazon Bedrock, or, with other, that's just the example that I'm giving because I'm most familiar with it. That's a service that runs it. And AWS says like in their documentation, like that they don't use it to train on it. It's not sent to anybody else. Nobody else has access to it. So you have to trust them on that a bit, but at least you don't have to run your own model.
Yeah, well, I think we could probably carry on talking about this stuff for a lot longer.
Yeah.
But I think we should also round off the conversation here. And I want to do that by saying thank you very much. I've really enjoyed hearing your thoughts about the work that you've done and where you think it might end up in the future. It's been absolutely fascinating. Really appreciate you taking the time to share that with us. Where can people go if they want to reach out to you or learn more about this natural language geocoding that you're working on?
I'd say go to my company's website and you can find ways to contact us there. It is Element 84. So it's the word element followed by the number 84.com. And you can also Google Element 84 and natural language geocoding, and those things will come up. I spoke about natural language geocoding at State of the Map US conference, and that video's up on YouTube. And there's also the blog posts and things, and we'll try to get you the links for the show notes.
That'd be great. If you could send them through to me, I will include them in the show notes of this episode. Okay, thank you very much for your time. It's been great.
Hey, thank you.
Thank you very much for tuning in all the way to the end. It's much appreciated. I really hope you enjoyed that episode with Jason Gilman. principal software engineer at Element 84. There'll be a few links into the show notes where you can connect with Jason and read more about some of the work that he's done. And as I mentioned in the introduction, if you enjoyed this episode, I think the previous episode, Semantic Search for Geospatial, will tie in really nicely with this one, so please check that out. Okay, that's it for me. I'll be back again soon. I hope that you'll take the time to join me then.